Welcome back to the digital workbench. Look, if you've been relying on traditional static CAD modeling for a while now and you're finally ready to make that leap into parametric jewelry design, you are in the exact right place. I'm going to be your instructor for this explainer, and we're going to completely demystify a really core foundational methodology in AlgoJewels known as the chain of design. But to truly wrap our heads around how Grasshopper and Rhino work together to build these flawless algorithms, we're not going to start by staring at a wall of raw code. Instead, we're actually going to look at the jungle and figure out exactly how to navigate it.
So I want you to imagine your design journey as a digital grasshopper swinging its way through this glowing green matrix canopy. To get through it, you're going to rely on what we call the Tarzan Principle to master the really complex data flow of AlgoJewels. Think about it. Tarzan doesn't just close his eyes, leap blindly into midair, and hope he magically lands exactly where he wants to go, right? No, he swings from vine to vine, constantly transferring his momentum. In our world, you are that grasshopper, and you've got to learn how to safely swing through that parametric matrix.
In all my years of teaching this software, I've found this metaphor is hands down the best way to understand the chain of design. Let's map it out a bit. Over in Tarzan's world, he uses vines to build his momentum to reach a specific destination in the canopy. Over in AlgoJewels, your vines are your geometric curves. Your momentum is your data flow. And your destination, well, that's your perfectly finished 3D ring. You simply cannot jump directly from an empty screen to a finished piece of jewelry. It doesn't work that way. You absolutely have to grab those intermediary curves to keep transferring your data momentum forward.
Now listen closely to this part, because every single swing needs a rock-solid tree to start from. In the Rhino and Grasshopper environment, your very first tree is the absolute origin point in 3D space. Yep, the 0, 0, 0 coordinate. You can think of this as the literal Big Bang of your digital universe. It's the core structural anchor that your entire parametric design is going to outwardly expand from. If you try to start anywhere else, like if your starting point is just floating loosely out there in uncalibrated space, every single vine you try to grab later on is going to swing wildly out of alignment. You've got to start grounded.
That solid foundation usually begins with a base ring circle, firmly and precisely anchored right there at the 0, 0, 0 intersection. Your very first mathematical curve has to be totally grounded before you can even think about reaching out for that next piece of geometry. Because let's face it, if you don't anchor that first handhold securely, your forward momentum is going to fail before you even get off the ground. But once you have that baseline locked in, oh man, that's when the journey really begins.
Once you're fully anchored, your algorithm needs to constantly be searching for that next handhold. You're sequentially swinging your data forward. So you start by grasping your base ring circle curve. You use that momentum to reach out for a universal profile curve, and then you swing from that to extract your gemstone girdle curve. Make sense? Every single link is entirely dependent on the exact position and trajectory of the one that came just before it.
Let's take an ovoid profile maker as a prime example. This acts as a really crucial geometric link bridging a gap in your chain. If you somehow fail to connect this profile maker properly to your ring rail, well, your data basically just falls into a digital void. The whole algorithm shatters and throws a runtime error right in your face. The parametric handshake between these links has to be completely flawless. Every curve needs to know exactly which curve it's inheriting its momentum from. No exceptions.
Okay, so how does this momentum actually travel through the software interface? It's all about strict algorithmic order. Your parameters and inputs are sitting over on the left. They feed directly into the compute process in the middle, and that generates your outputs over on the right. And here is where the real magic happens. Those outputs automatically become the inputs for your next swing. You are just continuously feeding data forward, building up this beautifully unbreakable chain.
And because of that interconnected chain, we get something truly incredible called the parametric ripple-through associative modeling. Imagine just tweaking an input slider for something simple, maybe the ring size or the curvature, and then watching an entire 3-stone ring model dynamically update right in front of you. It's basically like shaking the very first vine Tarzan is holding onto. Because the entire path is linked together, that one single motion cascades instantly through the whole design.
Let's actually trace how that ripple effect sequences out. You nudge that slider, right? Instantly, the ring size diameter shifts, and because you built a flawless chain, that shift pushes the shank surface outward. That outward movement then carries the entire gemstone setting up to a brand new height, which then automatically forces your claw positions to recalculate. Keep in mind, we're working in a field that relies on crazy tight tolerances, like 0.1 millimeters, yet the slightest slider adjustment recomputes all your shanks, bezels, and claws in real time, and you didn't have to redraw a single line. It's brilliant.
Which actually brings us to a bit of a master instructor's secret. Remember, Tarzan never ever jumps without looking right at his landing pad first. If you want to build a genuinely successful algorithm, you have to envision the totally finished piece of jewelry first, and then design it backward down to that 000 origin point. You simply can't build forward aimlessly. You have to lock onto your ultimate destination and visually trace that path of curves all the way back to your starting point.
So, let's say your home destination is this incredibly complex, fully finished parametric engagement ring, totally decked out with stars and intricate little details. When you design backward from a masterpiece like that, you are charting the exact sequence of vines you need. You start realizing, okay, to get those final claw prongs, I'm going to need the gemstone curve. To get the gemstone curve, I need the bezel setting. And to get that setting, I need the main ring shank. You're literally just mathematically reverse engineering the entire journey.
By maintaining that strict data continuity and really leveraging these associative networks, you are basically guaranteeing your success. The chain of design connects everything. It ensures that your transition from a rough concept to a functional physical creation is infinite and dead-on accurate. If you just map your curves, anchor your base, and maintain that momentum, your digital grasshopper is going to land safely on a beautifully balanced, fully parametric piece of jewelry every single time.
So, as you pull up to your own digital workbench today, I want to leave you with this. Where is your final destination, and what is the very first vine you need to grab to actually get there? Figure out your path, anchor yourself firmly at 000, and start building your unshakable chain. Have fun with it, and I'll see you at the workbench.